Through this tutorial, I'll be helping you to build your own COVID-19 bar chart trace using Python. There are certain prerequisites to working with this project, which include knowledge of basic Python and familiarity with libraries like pandas, matplotlib, numpy, and opencv. Before starting with this project, you must install packages such as kaggle, pandas, matplotlib, numpy, opencv, and pillow. I'll be working with the Genie editor for this project tutorial, and I have already created a Python file called bar chart trace. We'll be working with the novel coronavirus dataset offered on Kaggle. When we start with our machine learning or data science career, we usually tend to download the whole dataset and then copy it to the directory where our Python file is located. But in this case, the dataset is updated each day, and we require a mechanism for the dataset to be downloaded automatically to our current working directory or subdirectory by the Python script itself without having to visit the Kaggle website each day. And the Kaggle API lets us do just that. So let's start by copying the API command. Copy API command. Let's paste it in here. Now we won't be working with the command directly, so let's comment it out for now. We can now start coding. Import Kaggle. Let's define a function called download. Kaggle dot API dot authenticate. For this line of code to work, you should have your kaggle.json file downloaded and saved to your .kaggle subdirectory of your root directory. If you haven't done that, make sure you do that. Kaggle.api.dataset underscore download underscore files. Now we can use the final portion of the previously copied API command and pass it as a string. We can also add unzip equal to true so that the dataset will be unzipped after downloading. And let's print out whether the download has been successfully completed or not. So this line will be executed only if there wasn't any error in downloading. And we can make a few changes by doing this command. So for Windows users, the kaggle.json file should be stored in C colon slash users slash your username, then the .kaggle directory. Now let's call our download function. We can see that the dataset has been downloaded to the same directory as our Python file. And I would not consider this as best practice, as it would be much better if we had the dataset downloaded to a subdirectory called dataset. And in the next session, I will teach you exactly how to do that using OS. Let's import OS. We can define a function called directories. os.make dirs dataset. Print directories created successfully. Now the final line of code would be executed only if the directory was created successfully. And the function os.makeDisk takes the name of the directory as an argument and then creates a directory with the name of the argument. So in our case, it creates a new folder called dataset in our current working directory. We can make a call to our directories function. And to ensure that the dataset gets downloaded to the newly created directory, we can give path equal to the name of the new folder, dataset. Compile, execute. So we can see that our directories have been created successfully. Yeah, our download was successful as well. So we can now observe that a new folder called dataset has been created and it contains the newly downloaded dataset. Let's just run the Python file once again. So now we encounter an error. Cannot create file when that file already exists, dataset. To overcome this error, we can import shuttle and make a few changes to our code. If os.path.access dataset shuttle.rm tree dataset. So os.path.access checks whether the given argument or the name of the directory exists, and if it does exist, then next line of called shuttle.rm tree of dataset gets executed. Now what rm tree does is it recursively deletes everything that is found inside your dataset folder, and then it finally deletes the dataset folder itself. So let's compile it again and execute it once. So this time we didn't encounter an error. We can create a function called directories underscore to remove our newly created directories once our project has finished execution. The directories underscore to if os.path.access dataset shuttle.rm tree of dataset. Print dataset directories deleted successfully. Let's make a call to our directories underscore function. So we cannot now find a directory called dataset. So our project created a new directory called dataset, then downloaded the novel coronavirus dataset to this folder, and then removed everything inside the folder and the folder itself. So if any of you are facing difficulty in finding the kaggle.json file, then go to the Kaggle website, my account, then you will find a button create new API token. After clicking this button, your kaggle.json file will be downloaded. Then you can copy it to the .kaggle subdirectory of your root directory. For Windows users, the exact path will be capital C, capital U, and Windows users of backslash. We can format the output a little bit by adding a slash n. Now start with our data analysis. For this tutorial, we will require only 3 CSV files. We can start with the time series COVID-19 confirmed.csv file. We need to copy the file name. Let's import pandas as PD. PD is the alias given to the pandas library. Let's define a function process. pd.read underscore csv os.path.join dataset. We can now paste the file name that we have copied. The head method can be used to print the first 5 rows of the dataset. Dataset is a variable name that I have given. os.path.join returns the concatenated value of the arguments using a directory separator depending on your OS operating system. So if you're on a Windows system, the directory separator used will be a backslash, and if you're on a Unix based system, the directory separator used will be a forward slash. Let's make a function call. We can comment out the directories underscore to function call for now. Let's compile and run it. We can now see the first 5 rows of our data set. The first column is province or state, the second column is country or region, the third column is latitude, the fourth column is longitude. From the fifth column, the column names are dates starting from 22nd January. For this tutorial, we will require only the country/region column and the columns from the fifth column onwards. Let's comment out the directories and download function calls for now. Let's see what happens when we print the first 20 rows. We can observe that certain countries like Australia are present multiple times in the dataset depending on the different province or state. For this project, we are only interested in country level information, and hence we need to create a temporary data frame containing only unique values from the country or region column for each date present in the dataset. Let's comment this out. Let's define dates as dates equal to dataset dot columns of 4 colon. We give the index value as 4 instead of 5 because indexing starts from 0 in Python. Let's define countries as countries equal to list of I for I in dataset dot log colon comma country slash region dot unique. We need to create a temporary data frame for each date in dates. For date in dates, let's define an empty list and call it cases. Cases equal to for I in countries dataset equal to dataset of dataset of country slash region equal to I. Let's create a new variable called total value. Total value will be the total number of cases occurred in a particular date for a unique country. Total value equal to dataset of dataset of date dot sum. Let's append this value to our cases list. Cases dot append total value. We can also format our date. Currently it's in DD YY format. We can change that to DD YY format. Let's define temp underscore list equal to date dot split slash temp equal to temp underscore list of 0, temp underscore list of 0 equal to temp underscore list of 1, temp underscore list of 1 equal to 10. Date equal to slash dot join temp underscore list. Basically, we swap the values at index 1 and index 0 using a third variable temp. We can now create our temporary data frame. Let's call it data. Data equal to pd dot data frame. We need to pass a dictionary. Let's call our first column countries. We can pass our countries list here. The second column will be date, and we can pass our cases list here. We can sort this data frame in descending order of total number of cases for that particular date. Data dot sort underscore values by equal to date ascending equal to false, in place equal to true. We need to give in place equal to true so that our changes are reflected in the original data frame. Let's print the first 7 rows of our newly sorted data frame. Print data dot head of 7 slash n slash n. Let's compile and execute. Thus, we have successfully managed to obtain the top 7 countries having the highest number of novel coronavirus confirmed cases for each date in our dataset. Since we are interested in only the top 7 values, we can write data equal to data dot ilog colon 7 colon. And with this, our data pre-processing is over. Now we can move to data visualization. Data visualization, we need to import matplotlib.pyplot. Import matplotlib.pyplot as plt. Let's do a horizontal bar chart of our data frame. plt dot bar h data countries data of date. We need to add plt.show, and let's give a break statement so that execution gets terminated after the first date. We can observe that countries with larger names are flowing out of the graph. To solve this, we can add list of first 20 characters of I for I in date of countries. So now we'll be using only the first 20 characters from our countries column. Let's compile and execute. We can observe that countries with larger number of cases appear towards the bottom of the graph. To solve this, we need to sort our data frame containing only the top 7 countries in ascending order for data visualization purposes. So let's copy this line of code and we need to give ascending equal to true. We can now move on to saving our figures. We can save figures to our current working directory or subdirectory using plt.savefig. Let's comment this out. We can create a new subdirectory called frames. Let's create a new variable called count. And let's define last as last equal to len of dates. We can increment the value of count for each date. Count plus equal to 1. And let's save our figure. plt.savefig os.path.join frames, comma, str of count plus dot png. Let's give transparent equal to true, dbox underscore inches equal to tight, dpa equal to 300, and face color equal to 0.8, 1, 1 to get a lighter blue background for our figures. So plt.close and we can print finish processing. Str of count plus slash plus str of last. We need to uncomment these. Let's compile and execute. Thus, we have successfully created 113 different figures for each date in our dataset. Let's view the images. We have now completed data visualization and we can move on to image processing. We need to import OpenCV and NumPy. Import CV2, import NumPy as NB. Let's define a function template. The template. We can create our template image using a 3-dimensional NumPy array initialized with the same light blue background that we used earlier. Template equal to nb.full shape equal to 1080, 1920, 3. Here 1080 is the frame height, 1920 is the frame width, and we gave 3 for our BGR values. Fill underscore value equal to 255, 255, 204. Dtype equal to nb.uint8. We can save our template using cv2.imwrite. cv2.imwrite template.png, template. You must note that OpenCV uses BGR instead of RGB. Let's make our function call. And we can comment this out. Let's add a print statement here. Template created successfully. Let's compile. We can now find our newly created template. To start with image processing, we need to open the images in Python, and cv2.imread allows us to do that. Template equal to cv2.imread of template.png, image equal to cv2.imread. Let's copy this path and paste it here. To resize this image, we need to import image from PIL. From PIL, import image. Image equal to image dot from array image RGB image equal to image dot resize one three two zero comma 800. So here 1320 is the frame width and 800 is the frame height. To get back our NumPy array, image equal to nb dot array of image. Before we continue with image processing, we need to add a few lines of code. plt dot access of. This will disable all the access and labels. In directories _2, we can add os.remove template.png. And finally, in the print statement, we can add a /n. Our objective is to position the bar chart close to the center of our template. Let's define origin _x equal to 480, origin underscore y equal to 190. For I in range, origin underscore y, comma, origin underscore y plus image dot shape of 0. For j in range, origin underscore x, comma, origin underscore x plus image dot shape of 1, template of I j equal to image of I minus origin underscore y, j minus origin underscore x. We need to manually add our country's labels as they were removed when we added the statement plt.axis of. We can add text to an image using cv2.putText. For I in range 1, 8, because we are considering the top 7 countries, cv2.putText template data dot iloc 7 minus I, comma 0 dot right justify 16 characters space dot replace we can give the coordinates as 150 comma 200 plus 100 into I. We can use the font cv2 dot font underscore Hershey underscore complex with a scale of 1. We'll use black color and a thickness of 2. Similarly, we can add the text for total number of cases for each country. We can add the date, our heading and our subheading. This time, instead of saving our images directly, we can consider them as individual frames that will make up our video. To start working with our video, we need to define our codec. cv2.video writer underscore forec mp4b. Forec stands for 4-character code and is used as an identifier for a codec. A codec is a software used for compressing and decompressing your digital video. We will be using the MP4V standard. So let's define our video as video equal to cv2.video writer. We can give the name of our video bar chart trace dot mp4. We can pass our codec here. We can use 30 frames per second and we'll set the resolution to 1920 by 1080. We can add frames to our video using the write function video.write template. To make the video more visually comfortable, we can repeat a frame 10 times. For I in range 10, and we can repeat the final frame 75 times. For I in range 75, video dot write template. We need to make a few changes to our code. We can save the figures as frame.png. Let's uncomment these. And we need to release our video. So let's compile and execute. Once our Python file has finished execution, we can come out of the editor. We can find our generated video along with the Python file, but other dependencies have been removed after execution of a Python file. Let's take a look at the video. Thus, we have successfully generated our bar chart trace illustration. Let's consider the recovered and deaths datasets. These datasets follow the same format and naming convention as our confirmed dataset. Thus, we can generate frames for these datasets by introducing a few changes to our process function. Let's define keys as keys equal to tuple of confirmed, comma recovered, comma deaths. For key in keys, process of key. We can move the body of our template function into our process function. Let's add key and we can remove our template function and the function code. Let's add if key equal to confirmed. We can generalize our process function by associating a template, a color, a face color, and a subheading with each key. Let's make a few modifications. In plt.barh, we can add color equal to color. In plt.savefig, we can change this to face color equal to face underscore color. And we can give our subheading. In the print statement, we can add plus space square brackets plus key closing square brackets. We need to make a modification to our dataset definition as well. COVID-19 underscore plus key plus .csv. So let's compile and execute. Once our program has finished execution, we can take a look at our finished video. Thus, we have reached the end of this tutorial. I hope you found this tutorial useful and that I was able to provide you with enough concepts to build your own illustration using Python.